Good day, everyone, and welcome back to my pre-calculus class. So, in my last video, I started talking about trigonometric identities and equations. And so far, we have looked at how to verify identities and how to create identities using all these basic trig identities that we learned before now. So, we also learned about using the sum and difference identities. So I talked about these formulas for cosine and also for sine. We solved some examples and we also derived similar formula for tangents. So, and we use that to solve some example as well. And you also have some try-its from the earlier work. So moving on, I want to solve further examples using the ideas that we talked about from the last lesson. So given that sine of alpha is 3 over 5, and it is between 0 and pi over 2, that is, it is in the first quadrant. You can see that alpha is in the first quadrant, 0 to pi over 2. So we have alpha here. It's in the first quadrant, Q1. Alpha is in the first quadrant. Then we have angle beta between pi and 3 pi over 2. That is, we have beta in the third quadrant in Q3. Okay, now we want to find all this, the exact value for sine of alpha plus beta, and so on. Well, we do know that, for example, say I want to answer sine of alpha plus beta. We know the formula is the sine of the first angle multiplied by cosine of the second angle plus, since it is sine, so plus cosine of the first angle multiplied by sine of the second angle. So we do know that we have sine of alpha, we have cosine of beta, but we do not have sine of alpha. Excuse me. We do not have cosine of alpha and sine of beta. So we need to use the information given to find these other trig values. So how do we do that? Well, recall that sine squared of alpha plus cosine squared of alpha equals to 1 always. Now, we do have sine of alpha to be 3 over 5, so I can square this plus cosine squared of alpha equals to 1. So that implies that cosine squared of alpha equals to 1 minus 9 over 25, which I can write as 25 over 25 minus 9 over 25, and that is 16 over 25. So that is cosine squared of alpha. And in the end, I can say cosine of alpha is taking square root on both sides. I will have plus or minus 16 over 25, and that is plus or minus 4 over 5. So that is cosine of alpha. Is my answer positive or negative? Let's see. Alpha is in the first quadrant. Here, alpha is in the Q1, so meaning cosine is positive here. So I can conclude, therefore, cosine of alpha is 4 over 5. I also need to do the same thing for beta. Also, sine squared of beta plus cosine squared of beta is 1. I I do know that cosine of beta is negative 5 over 13, so I need to square that. So sine squared of beta, so equals to 1. Now sine squared of beta is 1 minus 5 over 13 squared. Remember, I moved this to the other side. But this will not change since it is within the parentheses and I'm moving everything over. Okay, so this is 1 minus 5 squared, that is positive 25. 13 squared, that is 169. So I can write this as 169 over 169. Oh, sorry, so 169. And that is 144 over 169. And it turns out that um, sine of beta is plus or minus square root of 144 over 169, which is plus or minus 12 over 13. You should know the square root of this in your head. Now, beta is in third quadrant, meaning that sine is negative in the third quadrant. Therefore, sine of beta is minus 12 over 13. So we can return to our formula. Now, we can answer problem A, which is sine of alpha plus beta. I believe sine of alpha plus beta. Yes. So this is equal to sine of our first angle multiplied by cosine of second angle plus cosine of first angle multiplied by sine of second angle. So let us just fill in what we have. Sine of alpha is sine of alpha 3 over 5 times cosine of beta. Cosine of beta minus 5 over 13. Minus 5 over 13 plus cosine of alpha 4 over 5 times sine of beta minus 12 over 13. So this is minus 15 over, oh, we don't need to do that. Since this is multiplication, then we can have 5 here, 1, 5 here, 1. So we do have negative 3 over 13. Plus times minus, minus. So that is 48 minus 48 over 65. Okay, so I want this to have the same base, I can multiply this by 5. So in the end, I would have minus 15 is the same thing. Okay, go back to over 65 minus 48 over 65. And we have negative 63, I believe, over 65. So if the arithmetic there is correct, then that should be the answer. The next one is cosine of alpha plus beta. So there is nothing fancy here that we are doing now. We're just filling in what we've had. Cosine of alpha plus beta. So, which is cosine of the first angle multiplied by cosine of the second angle minus, since here is positive, so that is minus sine of alpha, sine of beta. So cosine of alpha, let's see, cosine of alpha is 4 over 5 times cosine of beta, we have it given negative 5 over 13 minus sine of alpha. Sine of alpha is 3 over 5 times sine of beta, negative 12 over 13. Negative 12 over 13. So in the end, we have, I will just be smarter now and say over 65 minus, so this becomes plus, minus times minus plus, 3 times 12, 36 over 65. And our answer is 16 over 65. Looks like I cannot reduce that again, so that is the answer. I will skip this. You can just do that. It's the same thing. Let me solve tangents of uh, tangents. So this is D. So I will say C. C, do it yourself. Then D, tangents of alpha minus beta. So let us write the formula. That is tangents of alpha minus tangents of beta divided by 1 plus tangents of alpha times tangents of beta. We derived this formula in our previous lesson. Now, what is tangent of alpha, tangent of beta? Well, we need to find that. Let us solve it somewhere here. Let us solve it somewhere here. Tangent of alpha is sine of alpha divided by cosine of alpha. So which is, what is sine of alpha? Sine of alpha is 3 over 5. So that is 3 over 5 divided by cosine of alpha. We find it to be 4 over 5. 4 over 5. So that is 3 over 5 times 5 over 4. Here 1, here 1. So our answer is 3 over 4. We know that. Then tangents of beta. Also, that is sine of beta divided by cosine of beta. So that is sine of beta, sine of beta, that is minus 12 over 13, minus 12 over 13 divided by cosine of beta is cosine of beta minus 5 over 13. Cosine of beta minus 5 over 13. So that is minus 12 over 13 times minus 13 over 5. So can say 1, 1, and our answer is minus times minus. That is plus, so that is 12 over 5. Now we have everything. We can go back here and say this is equal to tangent of alpha is 3 over 4 minus tangent of beta is 12 over 5 divided by 1 plus 3 over 4 times 12 over 5. So that is it. And then if we solve the numerator, okay, let us solve the numerator somewhere. 3 over 4 minus 12 over 5. So I can multiply this by 4, then this by 5 to have the same denominator. So that is 15 over 20 minus 48, I believe, over 20. So that is minus 3 over 20. So that is minus 33 over 20 divided by, here I can say 4 here 1, 4 here 3 to reduce that. So solving that part as well, we have, let me also do it somewhere here. 1 plus 3 times 3, that is 9 over 5. So I can say this is 5 and this is 5. That is still 1, right? So this is 14 over 5. So 14 over 5 divided by 14 over 5. So this is minus 33 over 20 times 5 over 14. So it turns out that I can say 5 here 1, 5 here 4. Doesn't seem I can reduce anything again. So I can just claim that this is negative 33 divided by 4 times 14, 6, 1, 5. So answer. If everything goes fine with my arithmetic, then that should be the answer. Okay, so that is that. Let us quickly summarize what we did here. We're given something, some ratio, just like we did in a previous class. When we add a situation, when we're solving for inverses and we add something like this, let me remind you, let's say sine of cosine inverse of, let's say 3 over 5. Then we say the item here is not a special ratio that we can find on the unit circle. Then we use the idea of SOHCAHTOA, right? Creating something like this to find that, or using the idea that cosine of some angle is 3 over 5. And you can say cosine squared of A plus sine squared of A is 1. And you can find your sine. So just reminding you that this is not the first time we are seeing a problem like this. Okay. So you have some tribes here. Let me change this to tribes. So you have some tribes here. Show that cosine of pi over 2 minus theta equals to sine theta. Now you've seen this before when we studied cofunction. That we say cosine of 30 degrees is the same as sine of 60 degrees. And we say, oh, it is just the same as saying sine of pi over 2 minus 30 degrees, right? That is what cosine of 30 degrees is. Okay. So verify that using the now you can prove it now. The other time we use our intuition to say, oh, we observe that this is happening. Then we conclude here. Now you can actually prove it by using the difference of two angles. So just use the formula for cosine of difference of two angles. And in the end, you show that your answer is sine theta. Again, this is a situation where we say show, that is verify that the left-hand side is equal to the right-hand side. So in this case, take the left-hand side, use the formula, do something and something. In the end, your answer should be sine of theta. Okay, this is an example. Verify this. This is similar to what I asked you to do here. So verify this. How do we verify this problem? Again, I can see that the left-hand side is much more complicated. So I will say from left-hand side, which is sine of alpha plus beta plus sine of alpha minus beta. I want to show that if I simplify this, I'm going to arrive at this. And if that is true, then it is an identity. I can use it anywhere in the world. Anytime I'm solving a problem, I can use that. If I have all of this, I can just replace it with this. That is what identity means. Okay, let us see if we will be able to do that. This means sine of alpha multiplied by cosine of beta plus cosine of alpha times sine of beta. That is this part. Now this part, I have plus in between, so plus sine of alpha, I can create this so that there won't be trouble. So this for the first part, then the other part, that is sine of alpha cosine of beta. Since it is sine, I will have minus, then cosine of alpha sine of beta. It turns out that I have sine of alpha cosine of beta plus cosine of alpha sine of beta plus sine of alpha cosine of beta plus times minus cosine of alpha sine of beta. Now let us look at what we have. This is sine of alpha cosine of beta. Sine of alpha cosine of beta. I have two of that. So that is 2 sine of alpha cosine of beta. Here I have 1 cosine of alpha sine of beta minus cosine of alpha sine. Oh, that is gone. Right? Positive, negative, the same item. So gone. So this is what I'm left with. Is it the same? Oh, yes, it is the same. Yes. So that is the right hand side. So verified. What that means is that anywhere in the future where you have all of these, you can replace it with this. We can use it that way. That is what it means. So here I believe this is an example. Try it. I'm not going to solve this, but I will just, guide you. Look at this. All what you need to do is use the formula from the difference of two angles for sine here. Then divide each term by this. Maybe you'll be able to arrive at this. So do that. So this video is going to be very, very short. So this is the end. Make sure you do all the tries. Here we have 1, 2, 2, let's see, 2, 3. So I have 3 there. Then earlier we have 4. So this is you have 1, 2, 3. Under that 4. 4. Let's see if we have more. 4, 5, 6, 7, 8. All right. 8. Okay, so in total, you have 8 try it to complete and turn in our next class. So guys, I will be ending this video here, and I hope you have fun solving all this problem. So I will see you in class next week. Have a great weekend. Bye-bye.